time. New thing. Let's move this down here. I had to get my fat face out of the picture because first hour. What's wrong? All right. Everyone's panicking in the class because it's not. That's why you weren't responding. I had to do this because I had to restart my computer before you walked in, just to make sure the computer is fresh in its mind that we're going to be able to teach this. But I have to get my face off the screen because I made a video first hour, 33 minutes. Yep. And it was 140 minutes to upload to YouTube. I told you that, which is unacceptable for a teaching environment. So we're going to see how this goes, see how long it takes to compose after I finish this video. It'll probably be similar. You know what I will do, though? I'm going to go to I won't collect this. This is why you guys had one more assignment than fourth hour, because I did not collect that precursor, like the day after the test, or the day of the test assignment, because it was just an extrapolation. It was to set up an idea. So I will spend a minute to reference that key. Oh, look at this day right here. They didn't know what's happening Friday, although I looked at the weather. I think we're in bad news. There's going to be a lunar eclipse, and the moon's going to look like blood red. They call it a blood red moon. But then I looked. I think it's the first time we're getting rain, so it might be clouded out. I looked at the moon last night. Anyone? Oh, my backyard is like kind of lit up. It's so awesome. It's like right above my head. Around 10 o'clock. Okay, so right, did you get these right? All right. And then look at these two are equal in the middle. Interesting. Now, that's not really the true way to prove an identity, to just do one example, but it's at least something. Like an identity means it works for any angle measures I plug in. All right, well, we can assume that. All right, and then did you get this where the middle two were correct or the same, right? Okay, this was harder. Did you guys go through all of this? Did you go through all this rationalization to get these answers? That's where tan's going to be a problem, all right? Tan, you're going to have to do, some work on this. Hey, the two middle ones were, the second and the fourth are equal. Interesting. Then the last one, Group D, what was that one? Sign, again, a difference one. Okay, blah, blah, blah. So you're supposed to make these connections that we have some identities. And if you were able to come up with these yourself, you're in better shape. If not, then listen to me now. So the thing is, yes, these are not equal. All right, so that's not an identity. All right, that's what this is proving. You found a counterexample. I'm not even going to look at the graphs of this, why this is. I'm going to get into climbing into your brain how to memorize. Because guess what? You're going to have to, I just said the word, memorize these. But here's how I memorize it. You ready? Climb into my brain for a second, but only get the math. If you get the rest, you go instantly insane. Notice sign, the S-I-G-N-S, signs are the same. Sign, the signs are the same. That's a good start, right? And then I guess I have no other way to do this, but I always write this a little bit differently. This is how I write this in my head. I also know and have this memorized because I've done it for years, but my first thing I did to trick myself was, okay, I see the pattern. The sine, sum, and difference formulas are sine, cosine, but I always write it like this. So sine, cosine, sines are the same, and then I write it sine, cosine again, but I already did sine of alpha, so now it's sine of beta. I already did cosine of beta, so now it's cosine alpha. That's easy. So sines are the same, and sine is sine, cosine. Got it? Cosine, the signs are different. And cosine is cosine, sine. Cosine, the signs are different. Cosine, sine. I already got it locked in. I already got it memorized. Well, I've had it memorized. I was pretending I was a student. Next, notice tan. Tan, the numerator sign is the same. And then the denominator is opposites. And then what is the numerator? Tan plus tan over 1 minus tan tan. There's a 1. Got to remember the 1. Got to memorize the 1. Numerator, the sign is the opposite. So the bottom one is tan minus tan over 1 plus tan tan. That's it. I'm done. I got it memorized. All right. You'll take more time on this. And then what I'm blown away with here is your BC teachers are bringing up degrees. Whoa. Okay. But how many times have I asked you what sine of 30 degrees? Right? What's sine of 30 degrees? I don't know. Get out. Okay, what's sine of 30 degrees? Half. So what's cosine of 30? Not a half. The other one, root 3 over 2. Oh my gosh. How many A-Bers don't know what sine of 45 is? I want to throw up. What's sine of 45? Root 2 over 2. And then cosine, same. All right? So I've been talking about degrees forever, so we should be okay. So what I need you to do is change this. By the way, this is a problem. That's not 30, 45, or 60. Somebody raise their hand and tell me, what do you think equals 15 degrees that lands on my unit circle? What two angle measures? Raise your hand. Oh, I thought he was raising his hand, but he went, so he was moving his hand, but it was to do a big yawn. No, you didn't raise your hand. You're illegal. Arrest him. Yes. So what do I do with 45 and 30? I subtract them. So I write this in equivalency form. This is true. And then I use the cosine formula. What's the cosine formula? Is this minus or plus in the middle? Plus. And then what's cosine? Is it cosine sine or is it cosine cosine? It's cosine cosine. See, you already got it memorized. And then we've been talking about degrees enough that we can survive on evaluating with degrees. So it's real interesting. I feel like I don't know if we've ever written degrees on a paper. I can't remember with you guys. I know I did my own little set of notes for SOHCAHTOA, regular trig, 45, 45, 90s, 30, 60, 90s. So we definitely did at some point. What's cosine of 45, everyone? Root 2 over 2. What's cosine of 30? Well, sine of 30 is a half. What's cosine of 30? This is how we're playing the game, those that are severely and totally behind. What's sine of 45? And if anyone puts the word sine with this root 2 over 2, that just proves you don't know your basics. You sine an angle, you get a ratio. If you put the word sine in front of that ratio, I'm taking 1 point off of your test. It doesn't belong there. I'm talking about errors that I see all the time with students that don't get the basics. Now, what's sine of 30? 1/2. You know what else is great on this? I can pause the video. This is powerful. Yes, okay, it worked. All right. Oh, wait, I got to take a drink. I'm going to pause the video. I was thinking of burping right now, but okay. All right, so what's root 2 times root 3? Drink time's over. Put that away. What's root 2 times root 3? Root 6. Root. What's root 2 times what? Root 2. 2 times 2 is 4. And then, of course, you're going to get sick of these answers because there's not much we can do, not much uniqueness in how we can ask these questions. You're going to see root 6. Oh, I forgot. What's root 6 plus root 2? Root 8. No, it's not root 8. All right. Raise your hand. Remember, raise your hand. Can someone figure out what 255 might be? A sum or difference that equals 255 that are angles on our unit circle. Raise your hand. Oh, someone else tricked me. They just went like this and then they fixed their hair. Oh. Did you say 360? Huh? I couldn't hear you. I got these things on my ears. Okay, she got it wrong. No one can figure out a sum. This is fun. You look like you want to answer, new girl. No? You looked like you did. You're like, no, I better not. This is fun. I'll sit and wait. No one can figure out a difference or sum of angles that are on our reference. You know why, though? It's because you're not trained by degrees. This is why. So it's an unfair question. But I do want DOA. Well, it is 270 and then minus what? But that was 15 isn't on the unit circle. You got it? Hey-o! Look at this guy. Now, I know why they have a problem with this guy's on the internet. We've done only radians. Like AP says only radians. That's all we care about. So then in my AB classes, the AB teacher said, let's only do radians. I go, I think that's a mistake. I think they should know where the angle measures are on the unit circle as well. So here's 210, which is 30 degrees past 180. Isn't that a 30 in quadrant 3, right? And then, of course, 45. All right, so we have not done enough angle measures in degrees. So that's why that was hard for us. Understandable. That's why I'm shocked that they have these, in the examples. All right, really stretching your thinking. All right, what is sine? Positive or negative? What's my sign? Sine. Sines are the same. And then what sine? Is it cosine, cosine, or is it sine, cosine? It's sine, cosine. You already got it memorized. And then I really question those that can't memorize because I think they're copying keys and not even thinking about what they're writing. Because if you write this over and over again, then it just sinks into the brain. Just like when you write sine of pi over 4 is root 2 over 2, probably 100 times at this point in our class, right? Wouldn't you agree? In one assignment alone, you probably wrote sine of pi over 4 equals root 2 over 2 maybe 5 times on one assignment. How the heck do you not have that memorized? It's just ridiculous. Ridiculous. At this point, I got to call you out. You don't get called out enough. You don't. Except in this class. Wrong is wrong. Read that. Wrong is wrong, even if everyone is doing it. That's what for my A-Bers. Well, 12 of us got it wrong. That means the teacher's bad. No, 12 of you didn't do your homework either. And of those 12, 6 of you are absent 7 times out of 14 days. Wrong is wrong. Say it. Even if everyone is doing it. Let's move on. Okay. Ooh, teaching is so stressful. All right. What's sine of 210? It's a 30 in quadrant. Okay. Geez, she just yelled at me like, we get it, Mr. S. What's cosine of 45? Root 2 over 2. This is why I'm sad my face isn't because you don't see my expressions. What's sine of 45? Root 2 over 2. And then what's cosine of 210? It is negative root 3 over 2. I didn't write the negative. And then this is negative root 2 over 2. Plus, look at this. It's negative root 6 over 4. My bad, dogs. And 2 times 2. And then same things. Because really you can't, we can only do sum or difference angles if we can get a 45, a 30, or a 60 involved in this so that I can do it exact. And by the way, some people are like, why does this even exist? This is stupid. How many people might want to be an engineer? Raise your hand. I bet you there's a few of you. Engineers, if you don't get exact answers, and then you build a door for a Tesla car, are you going to work for Elon Musk? We hate him. Anyway, getting political now. If you put the decimal instead of that exact answer, that door is not going to fit on that car. Did you know that? So it's precision. We need exact answers. Anyway, let's move on. Now we're in our realm. I'm going to wait. I'll press pause. What are 2 angles that's probably going to be subtraction, right? Pi over 12 is pretty small. I need them in radians. I'll pause. What's pi over 3? 4 pi over 12. And then what was the other one you said? 3 pi over 12. Doesn't that equal this, right? Yeah. So this is equal to sine of the reduced pi over 3 minus pi over 4. And then you're going to get similar answers again. See, what your objective is, though, is to get an over 6, an over 4, an over 3 in there. I guess you could argue an over 2 as well, or like a pi or something, but it's usually the over 3s, 4s, or 6s. Then your answers are going to be very similar with a root 6 in it, a root 2, and it's all over 4. It's kind of thing. All right, sine. What do we have? Plus or minus? Minus, and then is it cosine, cosine? Or is it sine, cosine? Sine, cosine. See? I already got it memorized. Sine, sine, everywhere, sine. Do this, don't do that. Can't you read the sign? Does anyone know that song? Raise your hand. It's actually a great song. Anti-establishment song. Rules, rules, rules. Just like at Lockport, right? All these rules. All these enforced rules. Come on. What's sine of pi over 3? Root 3 over 2. Told you this is going to be happening all year long. My pen kind of went crazy. What's cosine of pi over 4? Root 2 over 2. Minus. What's sine of pi over 4? What's cosine of pi over 3? Sine of a 30 is a half. Cosine of a 60 is a half. And then here we go again. Root 6 minus root 2 all over a common 4. All these answers are hard to be any more unique than that. You want to get nuts? Now, this is why your middle ones I was worried about. That was the hard stuff you had to do. What is, someone's like, what did he write? It's really all the same, guys. Root 3 times root 2 is root 6. Root 2 times 1 is root 2, so it's root 6 minus root 2 all over a common 4. What? Okay. I'll wait. He can't answer. He already did it. Yes, ma'am.
Pi over 3 plus 4 pi over 3.
Again.
Which is 3 pi over 12.
That's what I wanted. You said 3 pi over 12 plus what? And then what's 3 pi over 12? So this is tan of, it doesn't matter who you write first. Tan of pi over 4 plus pi over 3. I hope I said pi over 4. All right, and then pi over 3. All right, now this is how I have tangent memorized. Tangent's a fraction. And then what's in the numerator, plus or minus? Plus, because I just taught you. The numerator follows the sign. And then the denominator is opposite. The denominator has a 1. Bless you, my child. You're not my child, sorry. All right, and then what's the numerator? Tan plus tan over 1 minus tan tan. So tan tan. Tan plus tan. And then 1 minus tan tan. All right, what's tan of pi over 4, everyone? Which is a 45. 1. What's tan of pi over 3? Okay, I always had a problem with this one, but I got it now, but I'm admitting a past problem. Back in the day, I was an always triangle guy. Opposite 30 is 1. Opposite 60 is root 3. Opposite 90 is 2. This is what I first taught you when we started trig in January. We did SOHCAHTOA of 30, 60, 90s. What's tan opposite over adjacent? So what is that? Oh, that's 30. Sorry, my bad, dogs. And over 3 is a 60, so it's opposite over adjacent, which is what? My bad, dogs. Root 3. Now, I know you got to memorize. How many people knew that right away? All right, fine. I'm trying to help those that don't. Sometimes tan is the biggest issue. 1 minus 1 times root 3, which I don't really need the 1. Now, I will tell you, if this was a 4-point question, I might award 2 points at this point. I do also have to say that I told you all year long, AP doesn't care about rationalizing, right? This is never going to be an AP question. We are going to extend a little bit. We're going to do more than we should, because the AP is very limited, I think, what they ask from a pre-calc class. You do, on the other hand, need to know how to rationalize in calculus. I believe, I don't want to make a fool of myself. We used to do it in pre-calc at the end. We would do calculus units. And trying to remember, I don't know if it was doing a derivative. I think it was doing a derivative. We actually had to rationalize a numerator, but you had to know how to rationalize is actually the case in a complicated format. I'm hitting that. Does anyone see? You don't see me. I think I lost my pen. There we go. I don't know. That's kind of bothering my brain, right? 1 times root 3 is root 3.